When you think about the most um, highly engineered piece of technology you own, you probably picture your car. Or, I don't know, maybe the smartphone in your pocket.
Right, yeah. We tend to prioritize the things we interact with directly. Like if it lights up or has an engine, we assume that's where the heavy scientific lifting is.
Exactly. But consider for a second that the most critical, relentlessly stress-tested defense system in your entire life is completely silent.
Oh, and it has zero moving parts.
Zero moving parts, and it's sitting right above your head at this very moment. I mean, we tend to treat home maintenance, and specifically roofs, like a boring chore.
Yeah.
Just a static lid on the box we live in.
Well, until that lid fails, right? Because the moment a single drop of water hits your living room floor, that silent defense system suddenly becomes your entire universe.
It really does. So welcome to today's deep dive. We're tearing into a highly detailed guide from a group called Roofing Council Bluffs, and it's heavily focused on asphalt shingle installation.
But, our mission today isn't to walk you through some weekend DIY project. We're really here to decode the hidden science of how this architectural armor actually works.
Right, and we want to explore the extreme environmental stakes here, specifically framing this around the Midwest and Iowa in particular, because the weather in the Missouri River Valley absolutely tests the breaking point of modern building materials.
Oh, absolutely. You're looking at a geographic region that essentially wages this invisible year-round war on exterior structures. To understand why a modern roof is designed the way it is, you have to look at the sheer violence of the environment it has to repel.
Okay, let's unpack this, because the specific mechanics of that invisible war go way beyond just getting rained on.
Oh, for sure. I mean, think about the Midwest. It gives you these incredibly humid, blistering summers. The ambient temperature might be 95 degrees, but the surface temperature of the roof,
It's got to be scorching.
it's pushing 160. The sun is just relentlessly baking the materials. And then fast forward just a few months and you're plunged into sub-zero blizzards.
Which is a huge swing. And that triggers something specific, right?
Yeah, that extreme temperature swing triggers a mechanical phenomenon known as thermal cycling.
Thermal cycling.
Right. So at a molecular level, as the roof heats up under that brutal summer sun, the materials physically expand. The polymers stretch, the wood decking swells.
And then winter hits.
Exactly.
Yeah.
The temperature plummets, and all of those materials violently contract. You can't see this happening from your driveway, but your house is essentially breathing, just expanding and contracting day in and day out.
Man, it makes me think of bending a paperclip back and forth. Like you bend it once, no problem. You bend it twice, it still holds.
But if you keep going,
Right, if you sit there and continually flex that metal, eventually the material fatigues. The structural integrity just gives out and snaps. So the house is that paperclip, constantly shifting and flexing with the changing seasons.
that analogy perfectly illustrates the concept of material fatigue. Because the roof isn't just one solid piece of plastic.
Right, it's a whole system.
Yeah, it's an assembly of wood, asphalt, steel fasteners, and chemical sealants. And all of those different materials expand and contract at completely different rates.
Which has to cause some kind of friction.
Exactly. Over time, that microscopic friction slowly backs the nails right out of the wood. It tears at the chemical bonds of the sealants. This is exactly why a tiny, invisible hairline fracture in July can turn into a massive structural failure by January.
Wow, and winter introduces a whole different kind of mechanical threat, right? One that bypasses the gravity-based design of a roof entirely. The guide details this phenomenon of ice dams.
Oh, ice dams are brutal.
And the physics behind how an ice dam actually breaches a home are wild, because it forces water to move against gravity.
They're a fascinating engineering failure, really. Primarily because the root cause usually isn't the weather itself. It's actually a failure of the home's internal thermodynamic boundary.
Meaning the insulation.
Right. We know heat naturally rises. So in a poorly insulated home, the thermal energy from the living space bleeds up into the attic, and it warms the underside of the roof decking.
Okay, so you have this thick layer of snow sitting on top of the house.
Hmm.
The heat escaping from the attic melts the bottom layer of that snow, right?
Yes.
And that turns it into water, which trickles down the slope of the roof, completely hidden under the snowpack.
Correct. But that water eventually reaches the eaves, the overhangs at the very edge of the roof.
Right, the parts that stick out past the walls.
Exactly. Those overhangs extend past the exterior walls, meaning they are not being warmed by that escaping attic heat. The temperature of the eave is well below freezing.
Oh, I see where this is going.
Yeah,
Yeah.
so that trickling water hits the cold eave and instantly refreezes.
Creating a literal dam of solid ice at the edge of the roof.
You got it. And this is where hydrostatic pressure takes over. As more snow melts from higher up the roof, the water flows down and hits that wall of ice. It just pools up.
Because it has nowhere to go.
Right. Because the water has nowhere to drain, the sheer weight and volume of that pooling water create pressure. And that pressure actually forces the liquid backward up the slope of the roof and underneath the overlapping shingles.
So it defeats the entire overlapping design of the armor just by attacking it from underneath. That's incredible. Which really raises the ultimate question here. If the environment is constantly trying to pry the house apart, bake it with UV rays, and drive freezing water up under its defenses, what is the optimal material to stop all of that?
It's a tough job.
It is. And the source material notes that across the United States, asphalt shingles absolutely dominate the residential market. But I have to say, reading the breakdown of how these shingles are actually manufactured completely changed my perspective.
Most people assume a shingle is just, a cheap piece of tar paper. But modern asphalt shingles are highly sophisticated composite materials. They rely on multiple layers performing entirely different functions.
Let's break down that anatomy. So, the foundational layer is a dense fiberglass mat.
Right, the skeleton.
Yeah, that provides the tensile strength. It prevents the shingle from just tearing apart when the house shifts or the wind pulls on it. Then, that fiberglass is completely saturated and coated in highly refined, weather-grade asphalt.
Which is the crucial part for waterproofing.
Exactly. The asphalt provides the hydrophobic barrier. It's the muscle that actually keeps the liquid water out. But the top layer, well, the guide mentions a heavy coating of ceramic granules. Wait, ceramic granules? I thought roofs are just tar and paper. Why are we putting crushed pottery on top of a waterproofing membrane?
What's fascinating here is that those ceramic granules serve a critical dual-purpose role as sacrificial shields.
Sacrificial shields, like they take the hit.
Exactly. Unprotected asphalt is incredibly vulnerable to ultraviolet radiation. If you just left the bare asphalt exposed to the Midwest sun, the UV rays would break down the chemical bonds in the polymer chains.
So it would just degrade.
Yeah, the asphalt would oxidize, dry out, become incredibly brittle, and just shatter at the first sign of an impact.
Oh, wow. So the granules are essentially microscopic armor plating that takes the UV damage so the asphalt doesn't have to.
Right, they reflect the solar radiation away from the waterproofing layer. And furthermore, the manufacturing process involves firing those granules with a ceramic coating that offers substantial fire resistance.
That is so clever.
It really is. You have a fiberglass skeleton to prevent tearing, an asphalt core to block the water, and a ceramic skin to deflect radiation and fire, all working together to create this waterproof, fire-resistant, UV-reflecting barrier.
It's a brilliantly layered composite, and when you look at the economics, it's super easy to see why it dominates. The guide points out that compared to, say, installing heavy metal panels or slate rock or clay tiles, asphalt provides decades of highly engineered protection.
And for a fraction of the upfront material and labor costs.
Exactly. Plus, there is a massive modular advantage. Like, if a heavy tree branch comes down in a storm and destroys a 3-foot section of your roof,
Yeah.
you don't have to fabricate a new custom metal panel, right? Or replace the entire slope.
No, you simply surgically remove the damaged composite squares and slot new ones in.
That's incredibly practical.
That modularity is absolutely key for long-term maintenance. But it's vital to recognize that not all asphalt composites perform the same under stress.
Right, they aren't all created equal.
The source outlines a distinct hierarchy of protection. There are 3 tiers of shingles, and they are engineered to handle completely different threat levels.
Well, let's look at the baseline then. Tier 1 is the traditional 3-tab shingle. It offers, what, a 15 to 20-year lifespan?
Yeah, around there.
Yeah.
And it's rated for wind gusts up to 60 miles per hour. It sits completely flat against the roof, and it is the most economical option.
Okay. Then Tier 2 introduces the architectural shingle, which jumps to a 25 to 30-year lifespan, pushes wind resistance up to 110 miles per hour, and features a thicker dimensional profile.
A significant upgrade for sure.
And finally, you have the luxury or premium tier, which stretches past 30 years of life, holds up against 130-mile-per-hour winds, and mimics the thick, heavy look of natural slate or cedar shake. But, I mean, why wouldn't anyone just buy the cheapest option if they're all made of asphalt?
Well, the jump from the baseline 3-tab to the architectural tier is where the engineering gets really fascinating. And it's why architectural shingles are now the modern industry standard, especially in places like Council Bluffs.
Let me challenge that standard for a second, though. If they're all made of the exact same three components, fiberglass, asphalt, and ceramic granules, why would a homeowner spend significantly more money to jump from Tier 1 to Tier 2? It's all just asphalt on a roof.
It actually comes down to mass, aerodynamics, and advanced adhesive mechanics.
Aerodynamics on a roof.
Oh, yeah. A 3-tab shingle is a single flat layer of material. In the Omaha and Council Bluffs area, the topography of the Missouri River Valley acts like a funnel for severe, high-velocity straight-line winds.
Okay, that makes sense.
So when a 70-mile-per-hour gust hits a flat, lightweight 3-tab shingle, the aerodynamic lift easily catches the edge of that material and just peels it back.
And once that edge is lifted, the wind drives the rain straight into the unprotected wood decking.
Precisely. That's the failure point. Architectural shingles solve this by utilizing a multi-layered construction. Manufacturers laminate 2 or more shingle layers together during production.
So they're literally heavier.
Yeah, this drastically increases the physical mass of the product, but it also creates an uneven dimensional surface profile that intentionally disrupts wind shear.
Oh, wow. So the varied thickness essentially breaks up the smooth flow of the wind, preventing it from generating that strong aerodynamic lift in the first place.
Exactly. That structural design, combined with thermally activated adhesive strips on the bottom of the shingles...
Wait, thermally activated?
Yeah, the strips actually fuse the entire roof into a single monolithic shield under the heat of the sun. That's how you achieve that 110-mile-per-hour wind rating.
That's brilliant.
It is. The premium tier simply adds even more mass and more laminations for absolute extreme weather environments.
Okay, so you invest in the heavy aerodynamic architectural armor. But the environment never stops testing those defenses. The guide details how to read the subtle warning signs of structural failure long before a catastrophic leak ruins your ceiling.
You really need to catch these early.
Definitely. And the first indicator connects directly back to our anatomy discussion, which is granule loss.
Right. Finding a heavy accumulation of coarse, dark sand in your gutters is a major red flag.
Because those are your microscopic ceramic shields washing away, right? And without them, the sun is beginning the process of oxidizing and destroying the waterproofing layer underneath.
Spot on. Another critical visual indicator is missing or cracked sections.
From hail and wind and stuff.
Yeah, whether from severe hail impacts fracturing the fiberglass mat or sheer wind force tearing a section away. Any physical break in the overlapping system means water infiltration is no longer just a possibility. It is an active inevitability.
Yeah, it's going to happen. And obviously, if you were seeing brown water stains on your interior drywall, the battle is entirely lost.
Oh, absolutely. The exterior armor failed long ago at that point, and the water has been quietly making its way through your attic and insulation.
But here's where it gets really interesting. The most surprising warning sign detailed in the guide completely subverts expectations. Curling and cupping.
Yes.
You look up and see the edges of the shingles literally bending upward like potato chips. It looks like the harsh summer sun has just baked them into warping. I get why wind causes cracks, but why would a shingle just curl up on its own?
Well, it looks like an external weather attack, but in the vast majority of cases, curling and cupping are actually symptoms of a severe internal flaw.
Internal, like inside the house.
Yes, it all ties back to the attic ventilation we discussed with ice dams.
So the house is essentially sabotaging its own armor.
Exactly. When an attic lacks proper intake and exhaust ventilation, the ambient heat and moisture generated by the living space become trapped directly beneath the roof deck.
Okay, so it gets super hot up there.
Beyond hot. That trapped, superheated air essentially cooks the asphalt shingles from the inside out.
It's baking the volatile organic compounds right out of the asphalt.
Right. It accelerates the chemical breakdown. As the moisture and oils are baked out of the bottom of the shingle, the material physically shrinks.
Oh, I see.
Because the top surface facing the sun is expanding and contracting at a different rate than the bottom surface being cooked by the attic, the physical tension literally forces the edges of the shingle to curl upward.
That is wild. You might be blaming the Iowa summer sun, but it is actually your own home destroying the roof from beneath.
It is a brilliant piece of structural sleuthing when you realize what's actually happening.
So when a homeowner observes the missing granules, the warped edges, or the cracked composites, how does the industry actually address the failure?
Well, it's a major operation.
Yeah, the guide from Roofing Council Bluffs outlines the replacement process, and it reads less like a quick repair and more like major orthopedic surgery for the structure.
The physical execution is a massive logistical undertaking, even though, a skilled crew can often complete an average single-family home in 1 to 2 days.
But let me play devil's advocate here for a second. Tearing off thousands of pounds of old asphalt seems incredibly labor-intensive and expensive. Can't we just save a bunch of time and money by slapping the new shingles directly over the old ones?
I hear that all the time.
Right. It seems like you'd get double the waterproofing layer.
Well, the layover approach is technically permissible in some very relaxed local building codes, but the guide heavily cautions against it for 2 major structural reasons.
Okay, what's the first one?
First, you have to consider the static load capacity of the home's framing.
You mean the actual wooden skeleton of the house?
Yes. Trusses and load-bearing walls are mathematically engineered to support a very specific maximum weight limit. When you add a second layer of dense, laminated architectural shingles, you are introducing thousands of pounds of completely unnecessary dead weight to the top of the structure.
Oh, man. And then winter arrives.
Exactly. Winter arrives and adds a massive snow load on top of that double-layered roof.
Yeah.
And you are pushing the entire structural skeleton of the home toward a dangerous failure point.
That sounds like a disaster waiting to happen. And the second reason is the hidden rot, right? If you just slap new shingles over the old ones, the surgical team never actually gets to see the patient's bones.
That's a great way to put it, because if the old roof failed, water made it through. That means the wooden decking beneath the shingles might be soft, decaying, or actively harboring mold.
Which you would never know if you didn't check.
Right. And driving brand new fasteners into rotting wood completely compromises the holding power of the new roof. A complete tear-off, stripping the exterior entirely down to the bare wooden decking, is the only method that allows contractors to inspect, identify, and replace compromised structural components.
It's a full system reset. They pull off the old armor, rip out the rotting wood, and then they start building the unseen layers of defense, because it's not just wood and asphalt, is it?
Not at all.
They apply a high-grade synthetic underlayment across the entire deck. This isn't the old paper that tears easily. It's a woven polymer fabric that acts as a breathable secondary water barrier. Then they target the high threat zones.
Right, like the valleys. The internal angles where 2 slopes of the roof meet are particularly vulnerable because they channel massive volumes of water during a storm.
To combat that, they install specialized ice and water shields. This is a thick, rubberized asphalt membrane that aggressively adheres directly to the wood, sealing perfectly around any nails driven through it to prevent that hydrostatic pressure from pushing water inside.
It's incredible material.
And then you have the edge flashing. They install customized metal drip edges along the perimeter. This physically breaks the surface tension of the water as it rolls off the roof, forcing the droplets to fall away from the house rather than wrapping around the fascia board using capillary action.
Every little detail counts.
Only after all of that hidden technology is installed do they finally lay down the visual layer of architectural asphalt.
And, the execution of those unseen layers, this raises an important question regarding the contractors themselves. The highest quality premium shingle on the market is completely worthless if the installation lacks precision.
So true. The guide is very clear about manufacturer warranties. If a contractor ignores the factory-mandated nailing patterns, or, say, drives a fastener too deep and fractures the fiberglass mat.
Or fails to properly sequence the metal flashing, yeah.
Right. If they mess that up, the multi-decade warranty provided by the manufacturer is instantly voted.
It highlights the difference between buying materials and buying a complete functioning system, which frankly ties into the harsh realities of homeowners insurance.
Oh, let's talk about who actually pays for this surgery. Because homeowners often assume their policy is a catch-all safety net for a new roof.
That's a very common misconception. Insurance policies are designed to cover sudden, catastrophic events. If a microburst drops a tree on your home or straight-line winds violently tear off a section of your shingles, your policy kicks in to repair that unpreventable damage. But, however, insurance explicitly does not cover negligence, deferred maintenance, or the natural degradation of materials over time.
So if you let the ceramic granules wash away, ignore the curled shingles for 5 years, and then demand a new roof because your ceiling is rotting out. Wait, the insurance adjuster is going to deny that claim, right?
Completely.
The failure was a predictable result of ignoring the warning signs.
Ultimately, the responsibility of maintaining the armor rests entirely on the property owner.
So what does this all mean? We started by looking at a roof as just a static, boring lid on a house.
Hmm.
But analyzing the molecular stress of thermal cycling, the advanced composite engineering of sacrificial ceramic shields, the aerodynamics of dimensional laminations, and the physics of hydrostatic pressure, it
Yeah.
becomes clear that a roof is a highly dynamic, actively functioning machine.
It absolutely is.
It is fighting a constant, brutal war against UV degradation, wind-up lift, and extreme temperature fluctuations every single second of the day.
It really is a remarkable feat of material science. But, reflecting on the entire guide, there is a broader conceptual takeaway here about how we view the spaces we live in.
How so?
Well, we inherently separate the inside of our house from the outside environment. They feel like two completely disconnected domains.
Right. Inside is safe, outside is weather.
Exactly. But the revelation about cupping and curling shatters that separation.
It really does.
Mm.
The realization that poor airflow and trapped heat inside your attic dictates the chemical lifespan of the heavy-duty asphalt armor sitting outside in the elements. Listen, it forces you to rethink the entire structure.
It makes you wonder, what other parts of our homes are secretly operating as interconnected living systems? Where else might a hidden, seemingly unrelated flaw on the inside be quietly destroying the defenses on the outside?
Oh, wow. The call is quite literally coming from inside the house.
Exactly.
That is a brilliant perspective shift. Well, that brings us to the end of today's deep dive. We hope you walk away with a profound new respect for the battle-tested composite technology defending your living room from the elements. Keep questioning the everyday structures around you, and we'll catch you next time.